We examine C of x equals a cosine of omega x plus phi plus b. We use some identity for cosine and distribute a to get a cosine first angle omega x times cosine of phi minus a sine of omega x times sine of phi plus b. We compare with f of x equals root 3 cosine of 2x minus sine of 2x minus 1. It is obvious that b equals -1. The others are not as obvious, so I rearrange the factor. C of x equals a cosine of phi times cosine of omega x minus a sine of phi sine of omega x plus b. Comparing cosine of omega x, cosine of 2x, sine of omega x, sine of 2x, we found that omega equals 2. By comparison, we have a cosine of phi equals root 3 and a sine of phi equals 1. Square both sides of each equation, we get a square cosine square of phi equals 3, a square sine square of phi equals 1. And then we use Pythagorean identity to solve for a. We add the left side of both equations together. A square cosine of phi plus a square sine of phi square sine of phi. And then add the right side together equals 3 plus 1. Pull out the common factor on the left. A square times cosine square phi plus sine square phi equals 4. Take the square root on both sides. A equals plus or minus 2. And we choose a equals 2 for convenience. We substitute 2 back in the two equations we found earlier. We have 2 cosine of phi equals root 3. 2 sine of phi equals 1. Divide both sides of each equation by 2. Cosine of phi equals root 3 over 2. Sine of phi equals 1/2. The angle that satisfies both equations is pi 6, so phi equals pi 6. Substitute into C of x. We have f of x equals C of x equals 2 cosine of 2x plus pi 6 minus 1